Hey boys and girls, Mr. D here. In this video we're looking at how to solve and graph linear inequalities. Now, very similar to what we've been doing in the past couple of weeks as far as solving equations for variables. Really not a whole lot different until we get to the end, and I'll show you how we'll handle that. So this should be some pretty easy stuff. We're going to combine a couple different lessons from the textbook all into this one video here. So I think we can handle it. You guys are smart enough, and we've been doing it. So if you look here at this inequality we've got 4x plus 9 is greater than negative 3 times the quantity negative 4x plus 13. Really nothing different with this than what we've been dealing with for the last couple weeks other than this inequality sign here. And so I slid over here this key note, which you have to make sure you get down, put some stars next to it. This is really important. Just ignore this inequality sign for now. Just pretend that it's an equal sign. You know, we'll do all our maneuvering, shift all the variables and terms around. Then we get to the last step. That's when we really need to focus on it, it being an inequality. So we'll come back to it then. But for now, let's just solve it as if it's a variable and an equal sign. Okay, so I got two variables here. I got a variable on each side. Variable inside a parenthesis here. Negative 3 on the outside. Not a fraction or anything. So you know what? I'm just going to multiply this negative 3 through. I'll distribute it through. If it was a fraction out here, maybe I would just multiply both sides by the denominator to eliminate the fraction. But here it's an integer. We'll just multiply it through. Negative 3 times negative 4x. It gives me positive 12x. You know, right here. There we go. Positive 12x. Negative 3 times 13 is negative 39. Okay. I'll bring down my inequality sign for now. Still just pretending it's an equal sign now. I don't want to change it to an equal sign or just ignore it. Like, I want to still bring it down with me because we need to have an accurate measure of that when we get to the end. Alright, so we still have variables on both sides here, 4x and positive 12x. I'm going to bring the 12x over to the left. Just for this example, we'll do it this way. So we'll do minus 12x because it's positive 12x here. Minus 12x. Our x is here, they cancel out. Over here, negative 12x and 4x, that'll give me negative 8x. Plus 9 is greater than negative 39. Alright, let's move this 9 over to the right-hand side. So let's subtract 9. Subtract 9. Okay, these 9s are canceled out. Negative 39, negative 9, well, that's going to be negative 48. Okay, negative 8x. Alright, so negative 8x is greater than negative 48. Now here's where we need to pay attention to the inequality. We almost have this variable alone. So here's what we have to do. We have to take a look at this rule right here. And again, you need to write this rule down. This is critical. If the last step is dividing both sides by a negative number, then we have to flip the inequality sign. So if you look here, what's going to happen? To get this x alone, we have to divide both sides by negative 8. Okay, so over here, negative 8 over negative 8, well, it's positive 1x. So that's x. On the right-hand side, negative 48 divided by negative 8, well, that's just going to be positive 6. But when we look into this rule, we divided both sides by negative 8. So we have to take this inequality right here. We've got to reverse it. We've got to flip it. So what we really end up with is x is less than negative 6. So we've solved for x. Now what we need to do is we need to graph it on a number line. Okay, so our answer, x is less than 6. All right, let's type that in right here. X is less than 6. Whoops. Okay. So this is what we need to graph right here. So if we make up our line, we'll make this 0. Okay, 1, 2, 3, 4, 5, 6. Okay. Now, so here's where we're starting with our graph. One of the general rules I keep in mind here is this. And again, please make sure you jot this down. Just pick a number that's going to make the inequality true. So if we look here, uh, x is less than 6. What's a number we could plug in for x that would make that equation true? Well, let's see. I'm going to pick 3. Um, pick any number you want for this, right? But 3 is less than 6, so I've made that inequality true. Okay. So now when I color in my solutions, when I shade my solutions, I really need to make sure that 3 is in my solution set. So 3 would be right about here. And I just need to make sure that I highlight this line, that this 3 is inside this solution set, because this is what makes it true. If you think about all these numbers here that are highlighted, these are my solution set for this inequality. Any of these numbers down here make this inequality true. Negative 10, negative 100, 1.4, negative 0.4, right? They would all be less than 6. The second I go right up here to 6.1, 6.2, 7, 10, 20, 30, none of those numbers are less than 6. That makes this inequality not true. Therefore, it's not colored in. Okay. Now, technically here, let's go over this next step here. You see here I have this open circle at the 6. If I plug in 6 for x, is 6 less than 6? No. So therefore 6, we leave an open circle there because it's not part of the solution. Now if we go back to the original problem, okay, and if I made this mark right here, if instead of just having greater than sign or less than sign, if we had the line underneath it which meant greater than or equal to, okay, now that changes up how we'll mark this up. So if we have, let's make one more number line here. Okay. So if we make this number line here, here's 0, here's our 6. Okay, and we'll use the same concept here. What we'll do is we'll say x is less than or equal to 6. So now that I have that equal sign, that's going to change some things up. Now I'm going to color in that circle because x can be equal to 6, right? If I made x equal to 6, is 6 less than or equal to 6? Absolutely. So now that's why we would color in that circle now. So now this circle gets colored in versus here not colored in when it's just an equal sign. Please make sure you make note of that. That's really important. Okay, and of course I would still color in all the way down here. For those of you guys at home, obviously you may not have highlighters. A lot of times what I'll do when I'm working with pencil on pencil, I'll do squiggly lines like this over the line to where my solution is. Okay, and then clearly this side is not the shaded inside. So just to go back and remember, just ignore the inequality sign and just pretend it's an equal sign until you get to the end. And really the only thing that matters with at the end is if I'm dividing both sides by a negative, which in this case I am, I've got to flip that inequality sign. The other point where it matters is when I go to graph. If it does not have the equal sign underneath it, it is an open circle. With an equal sign, we color in the circle. So you may want to make note of that as well. Equal sign, color in the circle. No equal sign in the equality, open circle. Okay. So when we get back into class, we'll do a bunch of practice problems with this. Hopefully you guys have some sense of familiarity with this and we'll get some smooth sailing and we'll cruise right through all this. I think you guys will do great. Okay, see you then. Bye-bye.